Okay, good morning class. So today we're looking at Euclidean geometry. We're looking at the examples for exercise 5. Whoops. Where are we? Exercise 5, which is on page 267. Okay, and it's number example 10. Okay, here's my marker. $265. Yes? It's exercise 4. Not 4 but 5 on page 267. Thank you. Right. Okay, so we'll spice up things a bit. We can't live life so easy. Or so boring, nah? When it's straightforward. Right. So here we are told circles ABC and ABD intersect at A and B respectively. People, what does respectively mean? In that order, where circle ABC is, where A is first and then B is second. Okay. AC is a tangent to the circle ABD. So if AC is a tangent to the circle ABD, what does that mean? That means to say that A1 is equal to angle D. Why? Tan chord theorem. Not so. Then we are told that BD is a tangent to circle ABC. So if that's the case, what do we know? We know that A2 is equal to C. Why? Tan chord theorem. So before going anywhere else, what can be concluded at this point? B1 is equal to B2. Why? Third angle in triangle. Then what can we conclude? So two triangles are similar. Once you got the two triangles to be similar, what can we do? You can work out our ratios. Not so. Alright. So that's it. The question says, prove that BC over AC is equal to BD, AB over AD. Can you see that, people? So by proving these two triangles are similar, I can go with the fact that the sides are in proportion. So what is the difference between this exercise and the previous one? The previous one, they told us which triangles we must prove. Here, we must draw our own conclusion to which triangles we need to prove. Okay. But since you guys are so fairly good and well versed in the previous exercise, this one's become easy. Not so? Yes. Right, so let's go with A. So we're going to say it's in triangle. In triangle, so I got ABC and triangle. Right, now the trick comes in. The order here doesn't matter in the opening statement. However, the order matters in conclusion. Why? Because our ratios are derived from the fact that they are similar. You understand? So again, the opening statement is not necessarily have to be in order. However, in conclusion it has to be, so that we can easily draw the sides that are in proportion. Okay. So we go A, B, C. So angle A is equal to which angle? To us, we said it earlier on. Angle A1 was equal to angle D. So we'll start with D in that case. Okay, then we went with B. B was equal to which angle? B. So it's B. I'm going to write that, that's it, okay? Because I need more space. Okay, so we say that angle A is equal to angle D. So we say in triangles ABC and triangle. So A was equal to D B was B, not so? And then C was A. Okay, so what can we say first? We can firstly say that angle A1 is equal to angle A1 is equal to angle DY, tan chord theorem. And then angle A2 is equal to angle CY, tan chord theorem. Am I moving too fast, people? I don't want to keep you during break here now. You guys are very busy people. You guys have better things to do, no? B1 is equal to B2. Why? It's the third angle in triangle. So therefore, what can we conclude? Therefore, triangle ABC is similar to triangle DBA. Why? Angle, angle, angle. And of course we can test here. Was A equal to D? Yes. Was B equal to B? Yes. Was C equal to angle C? And C equal to angle A? Yes. You guys see that? Ever answered the question? No, the question was regards to the ratio, not so. So we can conclude now. We can say that AB over BD is equal to BC over BA, which is equal to AC over DA. Why can I conclude this? Because triangle ABC is similar to triangle DBA. Let's see what they want. What do they want? BC, AC, AB, DA. Not so? So, BC in its right place, and AC has to be interchanged in. Not so? So what do I say therefore? BC over AC is equal to BA over. You guys understand? Yes. See any confusion here? Now, normally the similarity question is 4 marks or 3 marks. This one is going to be 5 or 4 marks. Sometimes 6, sometimes 7. Okay, depending on how complex it is to, or the steps you need to take to prove that angles are equal. Okay. Any confusion, any questions? No? Let's look at B. B is talking about AB squared. Right, so remember from the two triangles, what do we know? We know that AB is not B, no? AB over BD is equal to BC over BA is equal to AC over DA. Why? Because triangle ABC is similar to triangle DBA. Why am I going with this? Because there's again the ratios involved here. Not so. So what do they want? People, how do I get AB squared? AB times AB. Not so. So these are AB and these are AB. Not so. Then they want BC and BD. Okay, they couldn't have made it easier for us. Not so. So I can say therefore, what's AB times AB? AB squared is equal to BC times BD. Okay. Is there any confusion here? Right. Let's see if we can get something more challenging, no? You guys are asking, come bring on the grade 12 maths, man. You feel now that grade 11 was more of an issue? Yes, okay. This is on example 11, page 266. Right. People here they say PQ is equal, example 11, PQ and PS are tangents. So PQ and PS are tangents. Before I go anywhere else, what can be concluded here? That Q1 is equal to S2. Why? Tan co-theorem. Okay. Then S1 is equal to Q2. Why? Tan co-theorem. What else can be concluded there? That this whole angle here is equal to the whole angle here. Why? By observation, or we can say that PQ is equal to PSY, tangent from common point. Can you see that? Which will include, in turn then make those angles equal because of its angles opposite equal signs. Okay. So with that in mind, let's carry on reading. Okay. This is the only time reading isn't boring, no? Alright, geometry. Now we are told that to circle QRST. QRST, okay? So that's in order. Then we are told that ST, you guys will read more, no? Before I am told that I'm not promoting the great stuff and all that. Okay. ST and RS are ST, RS and RQ are chords. QS is joined. Then we are told that QP is parallel to ST. People, if this is parallel, what do we know? PQS, yes, which is this angle here, is equal to S3. Why? Alternate angles. Can you see that, people? Now the question says, prove that QR squared. So let's go QR squared with QR. This one here. So if it's QR squared, what does that mean? I must use it twice. Can you see that? So earlier on, how did I get AB squared? Is when I cross multiplied it. Not so. So I'm going to do the same here. I must cross multiply somehow or other here. Okay? So QR, RS, where's RS? This is RS, so I must pick that one up. And RP, which is this length here, so I must pick that also up. So which triangles would I work with? Q, R, S. So in that way I'll pick up this angle here. Oh, sorry, that length. And now I'm going to pick up this one by working triangle Q, R, P. You guys see that? No? So let's go. In triangle. So my order is not going to be right here. No? So it's going to be R, Q, P, and triangle R, Q, S. Okay, remember the order is not going to be right. So what can be determined here? Oops. Right, so what can we say? Can be said here? In these two triangles, we can say that Q1 is equal to S2. Why? Tan co-theorem. Okay. Another one. We know that R2 is equal to, sorry, Q2 is equal to S1. But this angle here, S1 is equal to angle T. Why? Why is S1 equal to T? I'm going to finish this one and the third one I'll record in the next lesson. Okay. So S1 is equal to T. Why? Tan co-theorem. Not so? And then T is equal to P1. Why? Alternate angles. You see that? So let's go. So it's going to be Q2 is equal to S1. Why? No, I don't need that. I can go with angles in the same segment, correct? As you can see here, here's the bow tie. Okay? So S2 is equal to T1, angle T. Angles in same segment. And it's coming from arc. R is, you don't have to mention the arc, okay? So angle T is equal to angle P1. Angle T is equal to angle P1. Why? Alternate angles with PQ being parallel to ST. Okay? So therefore, angle Q2 is equal to angle P1. Okay? And the third angle, of course, is going to be QRS. QRS is equal to angle R1. Why? It's the third angle in triangle. So therefore, triangle RQP is similar to triangle. Now the order is important. Okay? So R QS, which is the triangle. So R corresponds with R. Can you see that? R corresponds with R. Then Q corresponded with P1. And then P RQP and RQS. Okay. So Q corresponded with, my order is not right. So RQP is similar to triangle. So R was with R. No? And then Q was with S. Here we go. And then P was with Q. Why? Angle, angle, angle. So now we can conclude. Therefore, RQ over RS is equal to QP over SQ equals RP over RQ. Why? Because of the side, the triangles that are similar. So here they wanted QR square. So if you look at where QR is, so we need two QRs, there's QR and QR. Then you have S and P. So you all agree that those are the two ratios. Cross multiply, therefore RQ squared is equal to RS times RP. Okay? The sum is probably worth 7 marks. Alright? I'll do the last example in my next lesson and then I'll post it in your group. Good morning, class.